Our next presenter is Matthew Pawlik. He's going to speak on subsurface sewage disposal systems. Matthew's been an engineer with the Environmental Engineering Program at the Department of Public Health for over 20 years. He is currently the program supervisor. Matthew attended University of Connecticut and has a bachelor's degree in civil engineering and a second bachelor's degree in natural resource management. Matthew holds a professional engineering license and is a registered sanitarian. So, Matthew, come on up.
Good morning, everybody. Happy to be here today. As Tom said, my name's Matthew Pawlik. I'm with the Department of Public Health. I work in the environmental engineering section, otherwise known as the subsurface sewage section at DPH. So I'm going to talk about, I'm going to go down through, first I'm going to talk about regulatory jurisdiction, then methods of sewage disposal, what a subsurface sewage disposal system is. Basically, the non-technical term would be a septic system. That's what most people refer to it as, but in the regulations it's defined as a subsurface sewage disposal system. It's going to go into how we site them and design them, and then just cooperative efforts and things that I think that we have some overlap with the municipal folks, which you guys are here today, and also some questions that you may have. So I'll move on with that. So how on-site septic systems are regulated in the state of Connecticut is really two methods or two ways of breaking up the jurisdiction. Jurisdiction is through gallons per day or design flow of a facility. And again, we're talking on-site systems here, okay? So we're not on municipal sewer. This would be somewhere where municipal sewers are not available. With that said, though, so DPH, my group, does any on-site sewage disposal system with design flows less than 7,500 gallons per day, or 7,500 gallons per day or less. And then our partners over at DEEP, they have an on-site group similar to ours that they would regulate on-site systems with 7,500 gallons per day, or greater than 7,500 gallons per day. The only other thing that they also do is they also handle what we call alternative technology, alternative treatment technology specifically. And what that is just think of any type of mechanical device or even like a mini treatment system. That is also specific to DEEP, Department of Environmental Protection. So that would be irrespective of the design flow. So give you an example. So if I had a facility that had an on-site sewage disposal system and design flows were less than 7,500 gallons per day, but had one of these, what we call AT technologies on there, or anything other than a conventional septic system, which we'll talk about in a moment, it would still be regulated by DEEP, okay? So just to give you an idea, like some of these DEEP facilities will actually have like a xenon system on site. So I'm sure you guys might be aware of those. Are like prepackaged plants, that kind of thing. So again, just understand that it's not just the design flow, it's also if they have alternative technologies, so anything other than a conventional sewage disposal system. So right now, just like everybody else in almost every industry, we're hurting pretty bad when it comes to staff. Our program supervisor left about a year ago. I took over through him. So we lost that position and we lost my position because I jumped in his, and then we also acquired other duties. So at this point, it's just myself and another individual. We basically split the entire state up when it comes to on-site sewage disposal system. And the only good news to this is, you know, we oversee on-site sewage disposal systems, but ultimately, and I'll talk about it a little further on, the local health departments are the ones that are doing the day-to-day issuances of permits and things like that. So thankfully, obviously, there's no way two individuals could do that, but we're providing the oversight to those local health departments that are the ones that are overseeing the day-to-day permitting and enforcement and that kind of stuff for on-site sewage. But just to give you an idea, this is kind of our current program structure. Ideally, what we functioned in the past is we had 3 regions. That seemed to go well. We also actually have just, hopefully are going to be hiring 2 engineer interns within the next several months. But not that it's anything to do with this particular presentation, but we also handle things like public pools. We just got that. We acquired that duty on top of having less staff. We actually handle body disposal matters, which involve like mausoleums and crematoriums. I don't know why they put that with us, but they did. So we handle that. And we also handle campgrounds. So it's like one-stop shopping. But primarily, we do on-site sewage disposal systems. So, but just give you an idea of the pressures we're going through. So as you guys would understand, is there's really 2 main ways to dispose of sewage. You either connected to a municipal sewer system or you have something on site. And you can break down the on site into 2 categories, which what we did here on the slide. A conventional septic system, and that would be under our purview, being DPH, and again, we'll talk about that in a moment. But about 1.5 million people in Connecticut are on on-site sewage disposal system. So about 1/3 of the state is served by an on-site sewage disposal system. And then alternative technologies, those would be on-site systems that would be under DEEP's regulation. And currently the situation with that is you're only going to see those on large, like commercial facilities. You're not going to see these technologies on a small scale in residential homes, although we're probably one of the few states in the country that doesn't have that. And it's really just a jurisdictional issue at this point. In other words, there's really no permitting process to allow these small technologies to be implemented at the local or at these smaller levels. So that may change in the future, but right now as it stands, you're not going to see alternative technology on anything other than a large, let's say, shopping plaza or a school or something like that. It's not going to be at residential home, single-family home type of situation. So we'll talk about the components of a sewage disposal system. Again, this is ones that would be under our jurisdiction. I'll go through the different components. So here's just a basic slide here. And of course, some of the treatment trains are going to be similar to what you're going to see, obviously, at a treatment plant, just obviously at a smaller scale. So what we start with is building sewer, pipe coming out of the house, going to a large septic tank, which is nothing more than a settling chamber, settle out all the solids. And then you go into what we call a leaching field, drain field, which is going to consist of some type of trenching or other type of device that's going to treat and then discharge the sewage back into the environment. So what was different with our systems nowadays, and let's say maybe 60 or 70, 80 years ago, was back then people just put this stuff in the ground and wanted to minimize any exposure. So there wasn't any thought that went into, well, should we be discharging this stuff into a water table? That's not a good thing. So we've learned over the years, so our leaching systems are designed to actually treat the effluent before it gets back into our water table or into, ponds, lakes, or into ledge rock and directly into our ground. So ideally, if they're installed properly, that should happen. So they're actually pretty effective means of sewage disposal. So breaking it down a little further, you have your septic tank. So we have some photos here. These are huge structures. I mean, just an average size concrete tank, it's about 1,000 gallons. That's the smallest for any of our structures. It's about the size of a small SUV. So these things are good size. We also allow plastic septic tanks as well. That's been a good thing for a lot of sites that have issues with access, let's say. You can't get things in, heavy trucks and things like that. You can actually have a few guys actually carry some of these tanks. So when we have a site that we have a failure and we have limited ability to access the site, these are a good option. Obviously, buoyancy is a concern with these. There's ways to work around that. Most of the time, or the tank itself should function. It should always be full of liquid. Okay, so the only time that becomes buoyant is when they pump it. So what we usually do in a situation where we have high groundwater and we have one of these plastic tanks in, we just tell people to pump it in the summer months when the water table's at its lowest, so it's not going to pop out of the ground. But anyway, so you get it. I mean, these structures are there to remove all the sludge, most of the sludge, the BOD, some nitrogen gets removed, phosphorus, things like that. There are 2 compartments. We have a filter on there. They're pretty good. I mean, the quality that comes out of a septic tank is clear. It's clear. It should be if it's designed properly. So the larger the flow, design flow for a facility, the bigger the tank, right? Because obviously you need a larger retention time for more discharge to it. And then we have our leaching products. I mean, we have so many different kinds in Connecticut. And just kind of an interesting little side note here as far as Connecticut goes is the way we credit our leaching systems is kind of unique from the rest of the country. And what that's led to is a lot of these product manufacturers started out in Connecticut, and they're actually international now because we gave them the incentive to build these products because of the credit ratings, and so they went ahead and built them, and then other states or even other countries for that matter have accepted it. People like Infiltrator, Geomatrix, these are all manufacturers, Living Filter, these are all manufacturers that started out in Connecticut because of our crediting system and gave them an incentive, and now they're all over the country. But either way, the newer leaching system designs and what makes our crediting system more unique is we look at where the biomat forms. I'm going to show you a few slides. So again, a lot of this is going to be familiar to you because it's at a smaller scale than what you might see at a sewage treatment plant. So the expectation is this biomat is basically like a sort of a bacterial colony that forms on the perimeter generally of a leaching system, or in the case of our proprietary products, will form on the interface internally. And that's where we are sort of unique with other states because we give you credit for that. But at any rate, the idea or the theory behind it is that if you have more biomat or more bacteria colonies for a given area size, you get better renovation, better treatment. And that's what led to these products that are kind of unique to Connecticut. But either way, it's relying on a bacteria to process and deactivate the waste and treat the waste. And so here's just a slide just showing you that it takes time, obviously, for these colonies to form. And eventually they reach a steady state where it's sort of at equilibrium where the waste is coming in and it's having a certain ponding in there, but it's able to accept it and the bacteria are able to process it and you never overwhelm the system. So theoretically, they can almost last forever. I mean, there is a lifespan on these, I suppose, but if you pump your tank and you don't abuse your system, theoretically, the thing could last forever, theoretically. So go into a little more about siting and design here. So the thing to understand with our systems, as you can see, is they're soil-based systems. So we're relying on the soils of this site. So that kind of really sort of limits or has effect on development for areas that are not on sewers, because if you don't have the soil characteristics that are going to treat your sewage properly, then you may not get what you want on your property. You may not get the 5-bedroom house or the commercial building and whatnot. So one of the things we do is we go out and we dig big test holes, essentially, and we read the soils. And so we're looking for things like water tables. We're looking for restrictive layers, meaning a dense soil, or ledge rock and things like that. So our systems are designed our leaching systems are designed so that as the waste percolates from the leaching system, there's enough space between it and the water table or ledge rock so that enough treatment gets done before it gets into those areas of concern. So that's why it's very important that this step gets done, and it takes some time. We go out to the properties and read the soils. And so here, as I said, just give you an idea of what our standards are. So, once we find a water table, and sort of it's actually quite interesting. You can actually read the soils and you find these clues. They call them redox features. It's like a soil modeling feature, which is almost like a bathtub ring after you wash your dog, let's say your dog in a bathtub after it's real dirty, and then you drain the tub out and you see that ring around it. Well, this modeling or redox features are very similar to that. So we actually can see, we can see where the soil, where the water table was, even though it's not at its peak. So we can go out there anytime, and as long as we see that so-called bathtub ring, we're able to read where the water table is. And so we design on that. Because obviously you can go out in the middle of summer and the water table's well below the ground, and if you design your system based on that, you're going to be in the water table and it's not going to function at all if it's into the water table. So it's important to be able to read these things. And then we have our ledge separation. We do take into consideration coastal areas too. So tidally influenced, we ask that they put a better separation or an additional separation just to account for fluctuations and actually sea level rise. It's one of our concerns as well over time. So another component is a thing called a percolation test or perk test. People sometimes use that term kind of incorrectly. A lot of times they just use that as a generic means of all the testing that's done, and including the deep test pits. But the percolation test is just a simple sort of means of just assessing how fast the water moves through the soil in a saturated condition. So it's as simple as actually digging a 6-inch, 12-inch diameter hole, 12 inches deep. We pre-soak the soils so that way then we get it so they're saturated, because that's what you're going to see underneath the leaching trench. You're going to see a saturated condition, so we want to make sure we mirror that. And then we pour the water in, and then we simply just measure as the water level drops, we just record versus time. We come up with a rate. And then generally speaking, towards the end of the test, you're going to see a consistent rate, and that's what we design on. So a lot of states moved away from this. They do it by texturing and everything else. And my personal opinion on this, if you just utilize just texturing, you're missing a major component, and that is previous site use. So I'll give you an example. A lot of times when we do testing, let's say you want to do a subdivision and it's on an old farm where they were harvesting hay or something like that, and we're running a tractor over this field. And had that been like a forested area, and I ran a percolation test on it, and it probably would have run a lot faster than decades of a tractor going over it. So if you just did a textural analysis of the soil, which is basically just feeling it, you're not going to get the rate you're not going to be able to determine that that's actually been compressed and it's going to affect your design, because you're not looking at it in place. So that's, in my opinion, one of the good points of a percolation test, is because you're designing your system, you're not touching the soils below it, you're putting it in the ground, and you want to leave everything in place. So we want to get a test that's indicative of the in-place soils. So that's why I think it's a good way, and it's done us well in the state of Connecticut thus far. So we also look at a couple other things. I won't get too much into detail here, but we have a calculation called MOSS. It's just a silly acronym. Government loves acronyms. But it's just a simplistic form of Darcy's Law. So we actually incorporate that into our designs. And it just talks about that we want to spread our systems out. We don't like to compact them in a small area, so we overwhelm the soils or the groundwater in those areas. We find that they function better and they get better renovation when we use that. So cooperative efforts here. Just going to give you a couple of slides here I wanted to throw in at the end of where we kind of have somewhat of an overlap here. So one of the things that we have is we have a technical standards document, and that is sort of a cookbook design for septic systems in Connecticut. And the nice thing about it is we have a thing called a code advisory committee. So we want all of our stakeholders involved in this process. Everybody has input that's affected by this. We have our licensed installers, we have our local health officials, we have DEEP officials. You guys, as you can see, the municipal sewer, we have a representative of your group as well that comes in. We have soil scientists and engineers. So everybody gets involved. We vet these things. As a matter of fact, we're going to be making a change come January 1st, 2023. And when I just give you an idea of what these changes are, they're mostly technical things, like, okay, we're adding a new technology in there, we're adding a new approved pipe and things like that. So we want the stakeholders to have a say in that. We want their input, licensed installers. A lot of our things, or a lot of our, let's say, setback distances things are directly from these folks, our licensed installers. Do you feel comfortable installing a septic tank X feet from a house? When you're having this thing the size of an SUV on a crane, do you want it 10 feet? Do you want it 15? So we try to get everyone involved that has a perspective that we may not have. because we don't physically install the septic tanks. So the other thing I was thinking about before, when I made this presentation up, was just some of the things that I've known that we've had some interaction with sewer folks, and that is when you do sewer main extensions. Now, my department handles wells, but my section doesn't, but just wanted to throw this in here. So one of the things that I would recommend doing is when you have a sewer lateral extension in an area, is just try to coordinate with the local health departments. And the reason why is they have all of the wells information, private well information in their files, because obviously you want to maintain setback distances from your piping to these wells. And sometimes that doesn't happen, and then there's a big problem. You guys already laid the pipe, and then the well's 10 feet away, and then it's oh my gosh, what do we do? And so it's just better to handle that ahead of time and coordinate that with them. Generally speaking, just to give you an idea, I would say most of the piping that you would use, you probably could be as close as 25 feet for the most part. You wouldn't be able to get any closer than 25 feet for the piping that you use for your sewer extensions to a private well. So just keep that in mind. But again, I can't stress enough that it'd be just great to coordinate that with the local health departments. That way you don't have any issues. And the other one that we see, actually there's two in this slide here, is I'm sure you guys are familiar, and we actually deal with E1 systems ourselves, ejector systems with our septic systems. So I'm familiar with those as well. But keep in mind, though, that setback, and this really goes back to private wells again, if you're putting these in for individual houses that are lower than the lateral and you got to pump up, that these need to maintain well setbacks as well. And the minimum distance here is going to be 75 feet. So just keep that in mind. So when you're putting these in for individual businesses, homes, whatnot, if they're private wells in the area, be cognizant that they got to have a setback associated with them, which is going to be a minimum of 75 feet. So it's just important to know. And that's consistent with our code too. Any sewage structure is going to be a minimum of 75 feet. The only exemptions we have is piping, and that's why I told you guys the sewer lateral can come as close as 25 feet, and that's consistent with our code as well. The other thing I just wanted to mention is I know a lot of sewer utilities now have the whole FOG program with grease interceptor tanks and things like that. That comes up with us as well. But here's where the problem is. I mean, some we get asked our program, like, what's the setback for this, to this or that or the other thing? And I say, well, honestly, that structure is not governed by our regulations. The only thing in our regulations, that grease, and I'm talking about an external grease interceptor tank, hopefully everybody's clear on that. The only thing that I can say for sure that you have to maintain a setback is to a well, because the well regulations will stipulate that as a setback issue, okay? But as far as we get asked, well, how close does this, grease interceptor tank have to be to a building or a drain or anything else? I don't have an answer for it. I can tell you what we have in our code. We have setbacks associated with it. But when it's on a municipal system, it's sort of out in Neverland. There's no regulations that actually govern that, or there's no setbacks to my knowledge. Maybe there is, but I know for sure that wells is pretty much the one that I can tell you that you can cite that regulation. You got to be 75 feet. So if you have an external grease interceptor tank and there's wells in the area, keep 75 feet from it. So just as my last slide, and like I said, our program is decimated, but there are things that I would like to do in the future. We would like, a tracking and maintenance. We'd like to do more education. We'd like to have a statewide management system. We'd love to have somewhat of an SRF program, similar to what you guys have, to help homeowners, fix their systems. A lot of people, these things are anywhere from, 10 to or 20 to 30 to even $100,000 sometimes for a septic system repair. And that's a big kick in the teeth to a lot of people, especially when it's not like a new kitchen or a new car. You can flush the toilet again, that's about it. You can't look at it, it doesn't look pretty. So it's a big expense. So someday it would be nice to have that down the road. But first we got to get our staff up to par. So I'm going to ask if anyone has any questions. I'm happy to answer it. Anything at all about our regulations, any overlaps, any questions on what I had discussed about sewer and lateral extensions, well setbacks, anything? Sure.
USDA funding, is that available for rural residents for septic system repairs and replacement?
Yeah, that's a good question. So, yeah, that's not through the state of Connecticut, because that gets asked often. I mean, do you guys have money? And so on our website, I am aware of that organization as an entity. That is a potential for people, and I have seen it work for folks. A lot of those, to my knowledge, which it should be, it's usually income-based. And, but the ones that truly do need it, I believe they do get it. So that is good. And we do refer people to that. So that's a good question. Anything else, folks? Sure.
Yeah, so you mentioned that the issue with bringing advanced treatment systems down to the personal septic level is just a jurisdictional issue right now. And the traditional septic tank takes out about 10% of the nitrogen, where the ATS systems like they're using on Long Island can get up to, I think the highest is 87% removal. So there's a lot of incentive for that. Is it just jurisdictional? Would it just take a regulatory change or a legislative change? And how much funding would you need to transfer those duties from DPH or deep to DPH, right?
I can't thank you enough for asking that question. I got to tell you, because I got a lot to say on that. So that is quite a hot potato. So here's the deal, and I was the point person in our program. There's talks right now between our department and DEEP and another entity on how best to get that done. What you're saying is a statewide use of this AT technology. Here's the deal though, and because of the way that technology works is it needs maintenance and oversight. And I always say that's the Achilles heel. So with that is you have to track that, which means on the government level, we got to, and enforce. That's important, because and so what we've done, since I guess there's an advantage to being the last guy to do it, meaning the last state, because we look at what other states did and we say, okay, what went right and what went wrong? Well, that is what goes wrong with these, is when you don't follow up with enforcement and tracking. And why I'm telling you that is because unfortunately, and the powers that be don't want to hear this, it requires a fair amount of staff. So I'm saying, probably a good half dozen people, I think, to do that. And, the state of Connecticut generally frowns on creating more positions, especially a whole nother program. So it's kind of being tossed around between, our on-site people, meaning DPH, and DEP's on-site people, neither of which are now our coworkers at DEEP there, our partners, I should say, they're in the same position we are. They're down to 2 people, too. And so we're both in pretty much dire straits, but we tell them we need that stuff. So I thank you for that. But the bottom line is you need that oversight, and I know how I know what we have to get there, but it's going to require bodies, which means money, which government doesn't like to hear that. But that's the reality of it, because you can kid yourself like other states have done in Rhode Island and so on. They tell us, we put these things on there, we're not tracking, we go out there, the homeowner unplugs it, they're tired of paying, $200 a year for this person to come out and maintain it. And then now it's actually worse than a conventional septic system, because now it's, the leaching system is actually probably smaller than what it would have been otherwise, and now we're actually polluting the environment. Or worse yet, and this is the more interesting thing, because we have 2 sides right now that want to push for this. You have the environmentalists, and then you have the developers. And really, they see it 2 different ways. The environmentalists want to take pre-existing situations, use this technology to actually treat an area that we don't have the ability to do with a conventional system. I'm all for that. But the other side wants to take, let's say, a filled wetland or a wetland, and let's say develop. That's probably the most egregious example, but ultimately they want to be able to take an area that might not otherwise have been developable per our code and use it because of this technology. So that's kind of like a tricky situation that we have with that. But that's where it's at right now. All I know is I don't want to do that right now. We're not ready for that. So, but if in the future, if we got staff and we were able to do it, I think we probably could pull that off. But thank you very much for asking that question. So, Sorry, guys, I could talk forever on this stuff, so this is just to shut me up. Any other questions before I head out? No? Okay, great. Thank you. Thank you all.